Hello, welcome back, you guys. Let's get started on part 5. Have you found this page on your packets? Hope so. And if you haven't, please direct your neighbors on how they can look at the same thing as you're looking at right now. So now we're going to do some word problems, but the same skill. I know that solving linear systems for 3 variables is pretty difficult and pretty lengthy process. And when I get back, I'll show you guys how to attack these and check your answers really quickly on your calculators too. Maybe if you already know, you can actually show each other, okay? All right, but you guys, no worries. Let's read this question together. And let's, as we read, underline keywords. The sum of 3 numbers. Sum, okay, of 3 numbers. We know that means plus, right? 3 numbers is negative 2. So we know there's 3 numbers involved that we need to find. All right. So it's going to be, I don't know, maybe if you want to use x, y, z, sure, x, y, z. This is our goal, okay? The sum of 3 times the first number, the sum of 3 times the first number, twice the second number, and the third number is 9. You know, that's another sentence there. That's another equation, huh? The difference, we know that means something with a subtraction between the second number, and the half of the third number is 10. Here's another one. Every time that does that is, you know there's some equations going on. So let's start with the first equation. The sum of first 3 numbers is negative 2. Don't think of this anything difficult than a sentence. I'm going to tell you there's 3 numbers, and when you add them up, it's negative 2. So let's do that. X plus y plus z is negative 2. Let's do that, okay? And the sum of 3 times the first number, sum of 3 times the first number, 3 times the first number, that's 3 times the first number, twice the second number, and the third. They didn't say anything about the third, so no change there, is 9. That's another equation, okay? We're going to call this equation L. This equation we're going to call it O. This difference, now we know there's going to be subtraction going on between the second number, and half the third number is 10. All right, but you know, you guys, we don't like fractions, right? So why don't we rewrite that one? So let's multiply the everything by 2, so we get 2y minus z is equal to 20. And let's call that equation B, okay? You guys see if you understand these 3 equations that we've come up with, L, O, V. You see where we're going with this, all right? Now, what method is the best method? Is it going to be substitution or elimination? I mean, graphing, there's no way to do that. So let's see. Scope out your equations. We got this equation here, right? We got this equation here, this equation here, and this equation here. This one's already in terms of 2 variables. You got it. I heard you all the way from Bangkok. You're telling me that I should take equation B, rewrite in terms of z. So let's solve for z. Let's take z, which is 2y minus z equals 20. When we solve for z, what do you guys get? You're right. You get 2y minus 20. And I'm going to call that guy E. That's equation E, okay? So box that equation because we're going to use that sucker, okay? So let's replace it, you guys. Let's take L and O, okay? Let's replace, every time you see a z, you're going to plug in 2y minus 20. Let's do that for the first one. X plus y plus z. No, not z. Instead of putting z, we're going to put 2y minus 20 equals negative 2. O, 3x plus 2y plus z. No, not z. 2y minus 20 is going to equal 9. And let's simplify all that, okay? And when you simplify all that, you should get this. You should get x plus 3y is equal to 18. You should get here 3x plus 4y equals 29. So I'm going to put the equal sign better, okay? Equals 29. And you guys just do the calculation here and see if you get this, okay? And we're going to call this guy, let's give them names too. Let's call this guy R. Let's call this guy S, okay? Because we're going to refer back to them later. All right, so we have this equation. I know. You guys, look. Considering that we did everything right, can't we use these? And don't you guys already know how to solve linear systems with 2 variables and 2 unknowns? 2 unknowns and 2 equations? So let's do that, okay? Let's take equation R, and let's take S. Let's rewrite it here. I'm going to move it up a little bit. 3x plus 4y is equal to 229. And let's see what we can do here, huh? You're like, how about we use elimination here, huh? X, 3x, okay, if we multiply the top equation, R, by negative 3, we can add them together, right? So let's do that. Let's multiply this together, negative 3x minus 9y equals negative 54. And S, we did change S, so we're going to leave the S alone. And you guys, what happens when you add these guys together? What happens? Go ahead and try that. Did you guys get negative 5y is equal to negative 25? So what does that tell you about y? Y is 5. Yay! We found our first value. Woohoo! So you guys remember x, y, z, right? We always start there. And have we found 5? Yes, we found the second number already. All right, let's move on. So you guys, now we found the second number. Can't we use that second number to find the rest of our values? Of course we can. All right, so I'm going to change slides, but follow along. You have all that written down, right? All right, let's move on. So you guys, so far we have that y is 5, all right? Now, which equation can we use to find x? Let's say x, right? We can find z too. Oh, you guys, let's use e. Let's use e. Isn't z is equal to 2y minus 20 our equation e? And don't we know that y is equal to 5, you guys? So why don't we plug it in? Z is equal to 2 times 5 minus 20. So what does z equal? Negative 10. Woohoo! We already found negative 10 for z. Ow! All right. Now, how about x? We need to find x, right? X. And you could use any of these equations. You could use anything you want. But make sure after you find your 3 values, you plug it into every single one of these equations to make sure that it works, okay? Let's use r. Let's go ahead and use r. r was x plus 3y is equal to 18. Well, y is 5. So let's go x plus 3 times 5 equals 18. That makes x equal 3. And so we have z, x, so it's 3. You guys, 3, 5, negative 10. Seems like that's the answer. Go ahead and try it, you guys. Go ahead and try these values into our original LOV, okay? 1, 2, 3, and see if it satisfies all 3 of them, okay? It better. All right. If you didn't understand that, please, please, please ask your neighbors, guys, and slow down the video and watch it again. All right, let's move on to Totoro. And Totoro, did you guys know that Totoro is a girl? All right? Okay. Totoro has $1, $5, and $10 bills. You see that, you guys? I mean, that's how real life is too, right? We have like $1 bills, right? We have $5 bills. We have $10 bills, okay? In his wallet, worth $96. Whoa, he's so rich. Oh, sorry, she. Now, if she had $1 more, she would have just as many $1 bills as $5 and $10 bills combined. Okay? So we know that these are all statements, huh? All right? They might represent equations, right? If she had one more $1 bill, she would have just as many $1 bills as $5 bills and $10 bills combined. Combined. Keywords, okay? She has 23 bills total. Okay? So you guys, what do you want your variables to represent? I heard you. So you mean $1 bills, $5 bills, and $10 bills, A, B, and C. But what does the A, B, C really represent? You're right. A, think about it. If I have $1, it's worth $1, but it really depends on how many I have. That changes the amount of money I have. $5 too. If I have two $5, that means I have $10 really. So think about how we would do that. So A would be number of $1 bills. Then what is B? Number of $5 bills, right? And C, number of $10 bills. Because now when we do that, you guys, doesn't our money change? If I have 3 $10 bills, that's C is 3, that means it's 3 times 10. That makes $30 that I have. If I have 4 $5 bills, which makes B 4, that means 5 times 4, which gives me $20. Okay, try to digest that, okay? But let's start writing our equation. Let's do the easiest one first. We know for sure she has 23 bills total. That means I don't know how many A, I don't know how many C's, how many B's, but I know that they add up to 23 bills. We don't know how much of each though. Let's go to the second one. If she just had one more $1, if A, we just added one more bill, she would have just as many, same as $5 bills and $5 bills and $10 bills combined. What about the next one? Totoro has $1, $5, $10 bills. We don't know how many of each, but we know that it adds up to 96. And how will we represent that? Easy peasy. $1 every A, right? A represents how many dollar bills we have. $5 for every B, right? Depending on how many bills that she has. And 10 for every $10 worth every C, which is $10 So now let's organize the equations. So we have A plus B plus C is equal to 2NE3. We have A, let's write it in the STD form, guys. So we don't want this ugly form here, right? We want A, good, minus B minus C is equal to -1, because we've rearranged this into STD form. This guy, we don't need the 1 in the front, really, plus 5B plus 10C is equal to 96. Whoa, pretty large numbers. Okay, no worries though. Okay, and we're going to call this guy, A, B, C, all right? A, B, C. All right, next, what shall we do? It looks to me we can use A and B somehow, huh? Look, you guys, if we add A and B, think about what could happen. Let's do that first. But you guys, you can take any approach, okay? A plus B plus C is equal to 23. A minus B minus C is equal to -1. And when we do that, what do we end up with? We're going to add it, okay, guys? We're using elimination, aren't we? Then we get AA, that's 2A. Gone, 22. So what's A? Already, we got A is 11. Woohoo! So remember, guys, we're looking for A, B, C. We start there, right? Always. And it's going to equal A, B, and C is going to equal 11 here. All right. Now that we have 11, can't we go back to each of the other equations and plug in the 11 for A? Okay, let's do that. So let's go back to, which one do you want to go back to? Let's go back to this guy right here, A, okay? Let's go back to A. We're going to plug in 11. Don't we get 11, that's A, plus B, plus C, doesn't that equal 23? Okay, then when we simplify that, don't we get B plus C is equal to 12, right? All right, that's another equation that we have. Let's plug it back into B. A is 11 minus B minus C is equal to -1. Then when we simplify that, don't we get B plus C equals 12? Whoa, it's the same thing. So what can we conclude? Oh my God, B and C, number of bills for B and C, $5 bills and $10 bills is going to be 12. But we don't know how many of each. It could be, I don't know, 6 and 6. It could be 4 and 8, right? But we don't know that they're going to add up to 12 bills. Okay? And how about C? We could go 11 plus 5B plus 10C, it equals 96, or 5B plus 10C is going to equal 85. So we have another equation here. Or, you guys, look, there's a 5, 10, and 85. Can't we factor out the 5 there? So we get B plus 2C is equal to 17. Okay, so we're going to box all the important equations. Okay? All right, so now what can we do? You guys, we have these two beautiful equations here. Okay, but they're the same thing, so we're going to consider them as one. And we have this guy, but they're all in terms of B and C, and we already have A. So you guys, let's take B plus C is going to equal 12, and B plus 2C is equal to 17. Now let's see what we can do. Can't we combine these somehow? Elimination maybe? You're right. Why don't we subtract them? Okay? What's B minus B? Gone. C minus 2C is going to be -C. 12 minus 17 is -5. So what's C? You're right. C is 5. So if C is 5, we're almost done. You guys, isn't B plus C 12? That means C is 5. So what's B? You're right. It's 7. Because it's B plus C equals 12. C is 5. And 12, then B is 7. Okay? So let's count the bills. 11 plus 7 is 18. 18 plus 5 is 23. And it says 23 bills. If I add one more to this, you guys, isn't that 12? Isn't that equal to B plus 7, which is 7 plus 5? And plug it back into here so you make sure that's true. Alright, guys. I'm glad you've helped Totoro find out how much of each bill she has. Alright, the end.